In this video, we'll look at a review of index laws, zero power, and negative indices. Index, exponent, or power are often used interchangeably, but in different contexts. For the purpose of this video, I won't worry about the context. In addition, index laws are sometimes referred to as rules. In this video, I'm going to refer to them as laws. Whether you use indices later in life will depend on what work you decide to do. If you're contemplating any work associated with computers, cars, science, or design, then you'll more than likely encounter them. If a number or variable is multiplied by itself several times, it can be written in shortcut notation, referred to as index form. When written in index form, the number or the variable that is being multiplied is written only once. To indicate how many times it's being multiplied by itself, a small number is written above to the right-hand side of it. This is often wrongly or rightly referred to as the exponent, index, or power interchangeably. We say that A is the base number and M is the exponent, index, or power. The exponent is basically a superscript used to simplify larger mathematical problems. The whole expression is called a power, and we say that A is raised to the power of M. For example, if number 2 is multiplied by itself 4 times, it can be written as 2 times 2 times 2 times 2, which is factor form, or 2 to the power of 4, which is index form. In this example, 2 is the base and 4 is the power. You can also describe this as a power of 2. Now let's quickly review the index laws before we look at some examples. This is not a comprehensive look into each one of these, and they're not all known as laws, but I've included them here because they're important. When multiplying terms with the same base, keep the base and add the index or power. This is usually referred to as index law 1. When dividing terms with the same base, keep the base and subtract the index or power. This is usually referred to as index law 2. When raising a power to another power, retain the base and multiply the powers. This is usually referred to as index law 3. When multiplying two or more numbers raised to a power, raise each number to the power. Remember, the power of a product is the product of the powers. When dividing two numbers raised to a power, raise each number to the power. Remember, the power of the quotient is the quotient of the powers. Any term except 0 raised to the power of 0 is 1. Another way to say this is any non-zero number raised to the power of 0 is 1. This isn't usually referred to as a law. The laws can be used to prove this. When a number is raised to a negative power, it's equal to the reciprocal of the number raised to the non-negative power when the number is not equal to 0. Again, this isn't generally referred to as a law. Let's simplify some expressions using the index laws. I've tried to color code the variables and the original exponents in different colors so that you can follow them through the working. Here we have m to the power of 6 times m to the power of 5 times m to the power of negative 3 times m to the power of 0. We can rewrite this. We've rewritten m to the power of negative 3 as 1 on m to the power of 3, and we've changed m to the power of 0 to 1. Now we simplify further. We can rewrite this again with m to the power of 6 times m to the power of 5 divided by m to the power of 3. Using index law 1 and 2, keep the base and add and subtract the powers because we've got multiplication and division here. And that simplifies to m to the power of 8. Another example, we have x to the power of negative 6 times x to the power of 9 divided by x to the power of negative 5. We can simplify the top by adding powers because we're multiplying them. And then we take away the power from the bottom, and we've got 3 negative negative 5. We end up adding the 5, and we simplify to x to the power of 8. Let's look at another example. Here we've got a lot of multiplication on the top, so we can add the powers for the w's and add the powers for the z's, and that simplifies. So we can subtract the bottom powers from the top powers, so we get w to the power of 4 take 6 times z to the power of 8 take 5, and that simplifies to w to the power of negative 2 times z to the power of 3. Now we rewrite this with a non-negative power, and we've got z to the power of 3 divided by w to the power of 2. On this, we're going to use the power of a product as the product of the powers, so we essentially bring the power of 5 inside the brackets. Now we can simplify a to the power of 3 to the power of 5. We multiply them, and that simplifies again. We can do negative 6 to the power of 5, and we get negative 7,776 times a to the power of 15 times b to the power of 5. Again, we've got the power of the quotient is the quotient of the powers. So we're bringing the power inside the brackets, and we've got now the numerator and the denominator to the power of 3. Now we're doing the power of the product as the product of the powers. Now we bring the power inside the brackets, and everything inside the brackets becomes to the power of 3. And we've got to multiply the powers on the top and on the bottom. I'll simplify that, and we can simplify that further. That's as far as we can go with that. Let's look at another example. Use the appropriate index laws to simplify the following. Because there's quite a few steps, I'm going to go from left to right, top to bottom. The first step, we'll rewrite the expression to remove the negative power. On both the top and bottom, we have the power of a product is the product of the powers. So we're going to bring the power inside those brackets. So everything inside those brackets becomes to the power of 2 on the top, and everything on the brackets on the bottom goes to the power of 3. Then we've got to multiply those powers. We've got power to another power, we multiply the powers, and that can be further simplified. On the top, we can keep the base and add the powers. So we add them, we simplify it. Because we're dividing, we can keep the base and subtract the powers. And we're further simplifying this. And now we've fully simplified it, and we end up with 16 on 3 times w to the power of 3. Let's look at another example. Again, first we rewrite the expression without negative indices. Now we've got the power of the product as the product of the powers. In addition, we have a 0 power, so we can change this to 1 on the condition that both w and z are not equal to 0. And we can simplify this further. Now we can multiply the numerator and the denominator, and we can simplify 144 divided by negative 24. That gives us negative 6. Now we've got the same base on the top and bottom, so we keep the base and subtract the powers. So we get negative 6 times w to the power of 6 take 4, and z to the power of 10 take 3. And finally we get negative 6 times w squared times z to the power of 7. In summary, these are all the index laws we've used today. I'm not going to go through them again, but feel free to pause here and write them down if you haven't already. Please note there's more than one way to approach problems involving index laws. You should still get the same answer, but if you've approached the problem a little bit differently, it doesn't really matter. Thank you.